thanks everyone for coming. Excited to be speaking to you today. So let's get started. My name is Maggie, and I also don't have a April Fool's joke for you, but I do have a photo of me standing on top of a frozen lake, which is very similar to how I feel standing on this stage right now. I'm a site reliability engineer at GetYourGuide, which is an online marketplace serving millions of customers every day and running hundreds of workloads in our clusters. And today I'll be talking to you about a scalability issue we ran into in our Istio service mesh when we reached a scale of hundreds of workloads, and also how we solved this issue by running a cluster-wide rollout and collaborating with our developers on this project. So let's first understand what the scalability issue is all about. We have a Kubernetes cluster, and we have some services running in our cluster where the service-to-service communication is provided through Istio Service Mesh. I'm going to be talking about the sidecar model. However, similar principles would also apply in the ambient mode. So in this case, we have the search application talking to our catalog application, and traffic is proxied through the Istio proxy sidecar containers. All is good. Now, what happens when our catalog application scales up and there's a new pod? Can our search application immediately talk to this new pod of our catalog application? Well, not immediately. This is where the Istio control play comes in, namely IstioD. And IstioD takes care of figuring out there is a new pod, updating the configuration, and then propagating this configuration through our data plane. Now, this is what we want. And at this point, our search application can talk to both of the pods of our catalog service. So search talking to catalog is what we want, and Istio pushing the configuration is also desirable. However, with no extra configuration, IstioD will actually push configuration for all the other applications in our cluster, such as the location application, image. Regardless of if our application actually ever sends any requests to the service, IstioD will just push all this configuration across all of our cluster. And obviously, with few services running in our cluster, that's fine. But when we get to the hundreds, we start seeing issues. We start seeing lag on cluster configuration updates, which results to errors in the Istio networking layer. If it takes few seconds for our configuration to update, a workload can send traffic to an IP that is no longer available to serve that request. So we want to get rid of these errors. And finally, we also see an increase in cost, where the volume of the configuration is increasing. So the traffic of the Istio control plane is increasing. And also the resource usage of both the control and the data plane is increasing. And the increase is not justified. We're pushing configuration that we don't need. So it's a cost that we want to cut. So in an ideal state, IstioD would only push configuration for the services that we actually need to talk to. And as the title of this talk suggests, we can use something called the sidecar to help us achieve this goal. Sadly, we're not going to be riding a bike with a cute dog helping us with our networking configuration, but we're going to be looking at a somewhat confusingly named Istio resource called the sidecar. So how do we configure this resource? For a selection of workloads, we can specify a list of external outgoing hosts that our service wants to have configuration for talking to. These hosts can be in cluster in the namespace/DNS name format, but these hosts will also be external depending on the types of traffic that your Istio mesh is intercepting. And finally, maybe more interesting part of this object that might have some interesting design decisions is the behavior of what happens if your service tries to make a request to a host that is not listed in the egress hosts list. By default, this mode is allow any. That means that we still try to make the request. We're not blocking it. And that might seem like the safer, better choice to not interrupt service-to-service communication. However, what we found is that by choosing the registry-only mode, which actually blocks the requests as soon as a host isn't listed here, was a much safer choice for us. And why that is that what Istio does is that it blocks the requests and it sends it to what we know in the Istio universe as a black hole cluster. Why this is very useful is that we immediately know when a host is missing, and by the fact that we send it somewhere, we are able to actually figure out what this missing host name was very easily. So something that may have seemed like a riskier, more error-prone configuration is actually a safer and a simpler choice in this scenario. Great. So we have configured our resource, we've made some design decisions along the way, and what is left to do is for every workload in our cluster to figure out what are the external hosts that this service needs to talk to. Easy, right? Well, depending on your cluster, it might be. And the first question that we ask ourselves is this something that we can automate? And the answer to that is yes and no. What we can automate fairly easily is the standard case that our services are communicating without custom host names and without other layers of custom configuration. For this standard case, which in our case was roughly 90% or 95%, you can query whichever metric storage you're using, and you can just get data on your Istio metrics with roughly these labels, and that will give you the host names that you need for every single service in your cluster. For the remaining kind of 5% of some custom edge cases, fully automating this workflow will actually require quite a lot of effort and time. So we were a team of 4 SREs at that time. We did not have this capabilities and resources. So we decided to collaborate with developers. We realized that collaborating with developers is a very powerful tool that we have at our hands. It also made sense in this project. Developers are the ones that write these services. They probably know more about which services a single service needs to talk to than us SREs. We don't have this context. It was also a great opportunity for developers to learn a bit more about what is the infrastructure their services is running on and how do these things work. So win-win situation. We also wanted to make the collaboration as lightweight as possible and automate what we can. What we did is that we created automatic PRs with the configuration where we kind of gave developers the host names, the 90% I mentioned before that we could find. And then for the remaining edge cases, we wrote them a very simple runbook. And the reason why it was simple is that we were actually blocking the traffic as soon as a host name was missing. That meant that we had a very clear set of instructions we could give them on if they would know if a host name is missing. They would also know how to find them. And this way, collaborating, we were able to tackle this somewhat complex problem. And finally, we talk about automating the business logic, but it's also really important to automate the observability. And we want to automate observability both of the service and the business logic. So is there traffic that is being blocked? But on the other hand, when we're doing such rollout and collaborating, it's also very powerful and useful to automate the observability of the progress of your project. So at any point, you can check which are the services that haven't been rolled out, how is this team doing, etc. And by doing this, we were able to roll this configuration out to over 300 services in a span of really just a few weeks with no disruption. Given that we've kind of given developers the tools to completely break their services, I would call this a success. We've also achieved instant cluster convergence, where we also have some confidence that this convergence is going to stay for the future years, given the load that we saw before. That meant that we're no longer seeing any errors related to outdated configuration. And as a nice win, we also saw a 60% reduction in the resource usage of the Istio data plane. And to wrap up this talk and end on time, I'll leave you with a piece of ancient SRE wisdom, which says that the best time to declare your egress host was in cluster creation, and the second best time is now. So take this home with you. I'm happy to answer any questions. I wasn't able to go into all the details in the last 10 minutes, but feel free to reach out either on LinkedIn or GitHub or in person. Would love to talk about your use cases or our experience with this project. And that's it.